Good evening. Today we are going to discuss a few problems on the concept of analog and digital signal. While working the problem, we may get a better understanding about the concept. So what the first problem is, given a current I of t is equal to cos pi t ampere flowing through a circuit element with an impedance of Z equal to 4 plus J3 omega, where the J is a complex number which represents the imaginary section. Find the voltage V of t across the element. So, situation is given where the current flows through a circuit which holds the impedance of 4 plus 3J omega. You are asked to find the voltage across the element. Okay, what is the first step? We have to write all the parameters given in the problem, like the two parameters are given, current and impedance. Current is equal to cos 2 pi t ampere, whereas the impedance is 4 plus j3 omega. Already we have discussed in the previous section as the difference between resistance and impedance. The circuit which contains only the resistive element is known as the resistive circuit, and the circuit which contains both the resistive and reactive element is called as a circuit with impedance element. What is a reactance element? Which is that may be either inductor or a capacitor. The resistance arm which is added with either inductive element or the capacitive element is named as impedance arm, right? A resistor, along with that there will be an inductor or a capacitor or both. If there is only one element, means one imaginary portion, right? Therefore Z is equal to 4 plus J3 omega. These are the two parameters which is given in the question. Before proceeding the problem, we have to identify the magnitude part and the imaginary part. The magnitude part, as this is a complex number, the impedance is a complex number, we have to find the magnitude of the complex number. If the complex number Z is equal to A plus IB, the magnitude will be square root of A square plus B square. So similarly, A square is 4 and B is nothing but the coefficient of the imaginary portion, 3 square. So 4 square plus 3 square, the whole root is equal to 16 plus 9 square root, which is equal to 25 square root. Again, and the magnitude is 5. Whereas the phase angle is nothing but theta is equal to tan inverse of B by A. B is nothing but 3, whereas the A is 4. Therefore, it gives an angle of 36 point. So the next one is convert the current in the phasor form. Whereas the current is given as I of t is equal to cos 2 pi t. If it is converted into the phasor form, it will be the given term is in the form of rectangular. We have to convert into the form of phasor. Therefore, I is equal to 1. The phase angle is 0. Why? Because there is no imaginary portion in the current equation. So next is the calculate the voltage phasor. Whereas to calculate the voltage phasor, as per the Ohm's law, V through V along a closed loop is equal to the current flowing through the circuit into the impedance. Therefore, V is equal to I into R. We know what I is. I is equal to 1. The phase angle is 0. Whereas the impedance we have found as 5 magnitude with the phase angle. Why we have to convert the given complex number or impedance in the form of magnitude and phasor angle is, the complex numbers in the rectangular form shall be added or subtracted, whereas the complex number in the polar form shall be either multiplied or divided. So as to find the voltage around the closed loop for the given circuit, we have to follow the Ohm's law, which is equal to V is equal to I into R. I into R is nothing but in the form of a product. Therefore, we have to convert the current and the impedance in the terms of phasor form, so as to multiply the current and the impedance. Hence, current is 1 into phase angle 0, whereas the impedance is 5 into the phase angle 35 degrees something, right? So that product is nothing but 5 into the same angle. Again, the converting the voltage phasor as in terms of time domain, V of t is equal to the same magnitude, V is equal to 5, then cos of 2 pi t plus the phase difference. Therefore, the final voltage around the closed loop is equal to 5 cos of 2 pi t plus 36.67 degree. Right. So this is how we have to determine the voltage around a closed loop if the circuit is formed with the impedance element. Right. So hope you understood this problem. The next one is calculate the maximum data rate. Otherwise, it is called as channel capacity of a communication channel with a bandwidth B of 3000 hertz and signal to noise ratio of 300. Right. First, identify the given parameter. Bandwidth B is given and also SNR ratio 300. So as to find the channel capacity, we have to recall the Shannon channel capacity formula. C is equal to B into log of 1 plus SNR with base 2. The two things are given in the question itself, bandwidth and the SNR. First, we shall find the log base to 1 plus SNR. Log base to 1 plus SNR is equal to log base to 1 plus SNR is given as 300. Therefore, log base to 301. Right. So, the next step is applying the base conversions. Log base to 301 can be found with the help of a common logarithmic value of base 10. Log base 10 301 divided by log base 10 of 2. So this from the logarithmic table we can apply the values 2.47 and log base 2 is 0.301. And dividing the numerator and denominator, the answer is 8.23. And finally, multiplying that value with the bandwidth, C shall be is equal to 3000 into 8.23, that is nothing but 24,690 BPS. So this is the channel capacity or the bits the particular channel can hold on for fruitful transmission. These are the two basic problems to understand the concept of the impedance and also the channel capacity, that how much bits the particular channel could hold on if the bandwidth is 3000 and the ratio of signal to noise is 300. So hope the problem was understandable for you. Let us practice furthermore problems in our regular classes. Have this as an preliminary information so as to solve the problems in the same concepts what we have discussed today in analog and digital signals. Hope you have understood this class. Thank you for listening, students. Thank you.